Hi everyone, another somewhat long video for 15B. I'm going to just do this all in one part, but I'll show you how to do a few questions by hand, but the majority I'm just going to use the calculator just for time. And also you should be doing these questions on your own, not necessarily always getting me to do them, but the video is here to support you, but also remember your textbook has work solutions as well. So in 15B, we're looking at the mean and median for continuous random variables. Okay, so remember we've done the mean for discrete random variables. We did that back in chapter 13. And now we're going to do the mean for continuous random variables. So we look at the mean first, and then we'll look at the median. Now, not overly difficult, okay, so even though 15A and 15B are quite long, they're not necessarily overly challenging, not introducing new content to you. So let me just get my highlighter. All right, so your expected value, so remember we use expected value, it's the same as the mean, and we also use the symbol mu to represent the mean. Okay, so with this definite integral, we're going from negative infinity to infinity, but often they'll be bounded. So, you could have from C to D, like we do here. The only difference is when you're doing the mean, you're going to be multiplying your function by x. Okay, so see how that x is there? Maybe I'll do it in a different color so we can see it a little bit better. Come here. So we've got an x there. Basically, whatever you're finding the expected value of. So we're finding the expected value of x, but if x was a function, so if we can just scroll on, I'm going to be jumping back and forth. You can see here we've got the expected value of g of x. All right, so instead of having x in your definite integral, we have g of x. All right, so instead of x times f of x, it's just a function times a function. So we'll come back to that in a second. Well, not a second, but soon. So so if you think about the context of which we would use the expected value of continuous random variables, the example they give here is if we wanted to know the long run average value of something. So if you owned a shop or in this case, a petrol station, you might want to know, well, what is the daily demand for petrol at a service station? So the mean of this variable tells us the average daily demand for petrol over a very long period of time. So instead of just saying, oh, okay, last week from Monday to Sunday, this is what it was, you might want to know what it is over a long period of time. Okay, and that can help you in business and all sorts of things. So in example 5, it's quite basic because we're just finding the random variable x, the expected value of x. So you can see e of x there. Now, f of x, we've got a hybrid function here. So it's 0.5x, and we're going from 0 to 2. So usually you would have a lower limit and an upper limit, or maybe you've got just a lower limit and you're going to infinity. So remember in 15A when we introduce limits, so keep them in mind as well. It's always nicer when you've got a lower limit and an upper limit, so like we do here. And I've just realized I might just turn my emails off. All right, don't want anything coming through. So you can see the definite integral. We've got x because we're finding the expected value just of x. And here's our hybrid function, 0.5x, which came from, okay, so that's put in there. And we're finding e of x, so that's why we've got the x here. And then we're going from 0 to 2. So hopefully that all makes sense. Now, something we haven't been doing consistently is taking out any common factor. So here we've got 0.5. We can actually just take out the front of the definite integral. Sometimes it makes it easier when we're finding the antiderivative. Don't know why I highlighted that, especially if we're working with fractions or decimals like we are here. So the 0.5, because it's just a coefficient of, becomes a coefficient of x squared, doesn't change your antiderivative, so we can take it out the front. So when we're doing the antiderivative, we can just stick with x squared. Now there's nothing wrong with keeping 0.5 in and taking the antiderivative, but if you're doing this by hand, it's just easier to take it out the front. So you can see stays out the front, and then we do our substitution. So when we do our substitution, which they haven't done, but you guys should be familiar with this now. So just substituting in, I'll just write it here. So we've got 0.5, substituting in 2 gives us 2 cubed over 3. Whoops, I should put brackets around it, minus 0 cubed over 3. Now, if you're working with decimals and fractions, have them both in fractions. Fractions are easier to deal with. So 0.5 I've written as a half, and 2 cubed is 8. So we have 8 over 3. And then 0 cubed is just 0. So 1 times 8 is 8, and 2 times 3 is 6, and that simplifies to 4 over 3. Now, we're not finding the probability like we were in 15a. Okay, so don't get to that and go, oh, but it's greater than 1. It has to be between 0 and 1. We're not calculating the probability, we're calculating the mean. And when you think about it, your mean does have to be between 0 and 2. Okay, so just keep that in mind. All right, let's move on. All right, so you can see the calculator instructions, not that difficult. Yeah, I think they've forgotten to put the, let me just get my highlighter. The other domain, x is greater than 2, but clearly didn't make any difference. So here, yeah, they've done it with infinity to infinity, which wouldn't make any difference because it's going to be 0 everywhere else anyway. So 1.33 is obviously the same as 4/3, but stick to the lower bound and the upper bound if it is given to you. All right, so not a difficult question to do. All right, so this second part, what I said before is, well, just like we did with discrete random variables, you might be finding the expected value where x is a function, okay? So in this case, function of x is denoted by g of x. So instead of writing ex for your expected value, we write e of whatever gx is, okay, some sort of function. And then in your definite integral, we do g of x times f of x. Now the only all right, so these aren't equal, which is similar to when we did discrete random variables. But if you do have a linear function, I'm not sure whether I've got any examples of this here, you can just go straight ahead and do this. Okay, so I remember we did an example in 13D question. I remember it was a question 13 because I did it separately in class, not necessarily had it already in your notes. Okay, so you can still do linear functions the same way. All right, it's just a bit of a shortcut there. All right, now here we go. Okay, so I've only got one question here as an example, but that's okay. So the example up above from the textbook, that's an example of just finding the expected value of x, but now we've got functions. So for part A, we're dealing with 1 over x, and then for part B, e to the power of x. All right, and here's our domain, and here's our function. Okay, so all the important bits are highlighted. Sometimes I think I highlight everything. Okay, so your expected value, we're finding e, write big X, be consistent. All right, is equal to definite integral. We're going from 0 to 1. Probably should have done this over the other side because I'm going to do this one by hand. So g of x is 1 over x. So I'm going to write 1 over x as x to the negative 1. And notice when I'm writing the function, I don't use uppercase x. I'm just using lowercase x. So I think I've had a few students ask me, why do they use big X? I think it's that big X. Capital X just represents the random variable. All right, so x to the negative 1 is our function, and then we multiply that by f of x, which is 12x squared 1 minus x. Don't forget your dx on the end. All right, so I'm going to tidy up what I'm taking the antiderivative of. Okay, so x to the negative 1 times 12 to the x squared. All right, so that's going to become 12x. Negative 1 plus 2 is 1, so just 12x, and then 1 times x. I might actually do all that in one go. So again, just knowing your index laws. So x to the negative 1, and when the base is the same, times x to the power of 2, you add your powers. So negative 1 plus 2, think of it like this, x squared over x gives you x to the power of 1. All right, so if you get, hopefully you don't get confused by your powers because you should know them. All right, so we've got 12x. Let's just expand this bracket as well. So 12x times 1 is 12x, and 12x times negative x is minus 12x squared. Now you can take 12 out the front, which we're going to do. I might just erase that on the side so we've got a bit of space. 0 to 1. And then we're left with just x minus x squared. Now you can't subtract them, they're not like terms, so it's just x minus x squared. And then let's find the antiderivative. Keep the 12 out the front. Let's get my equal signs. All right, the antiderivative of x is we increase our power to 2 over 2 minus and increase that power to 3 over 3, and we're going from 0 to 1. All right, 0 is great because it's just going to disappear, so all we need to do is substitute in 1. 1 is also awesome because it's easy to do. 1 squared is 1, so it's a half, minus 1 cubed, which is 1 over 3. Now the biggest mistake I could have made there was not realizing that that had to be in brackets. All right, 1/2 minus 1 cubed, putting them as the same denominator, so 6. So we're going to have 12 times 1 over 6. So 12 times 1 over 6 gives us 2. All right, so I always check the answers with the textbook before I move on. And this answer is correct. The textbook didn't take the 12 out. So you might see, oh, it's a little bit different. But I think you would find this method a lot easier than leaving the 12 and doing the antiderivative. But, you know, personal preference, it's up to you. All right, now B, let's squeeze that in over here. Okay, so we're finding the expected value of e to the power of x. All right, so we're still going from 0 to 1. We're writing this function, so e to the power of x times f of x. Hopefully I'll write small enough I'll fit it in. Don't forget the dx on the end. Now this is just I don't think you would be expected to do this one. Is that supposed to be an x? Looks like it's square. No, that's not supposed to be an x. What is that? Trying to fit things in and I make a boo-boo. Hold on a sec. Forgot the x down the bottom. Just quickly put that in. 12x squared. All right, I would then just do it on the calculator. So let's go do it on the calculator. All right, so we've got a definite integral. We're going from 0 to 1. And we've got e to the power of x. And then times, you'll notice I often put 12 times in. That's because sometimes I think well, anyway, sometimes the calculator might be a little bit temperamental, so. All right, so we can just leave that. Actually, I wonder if it'll give us an exact value. Okay, so it's 36e minus 96. And if we were to write that from a calculator to 4 decimal places, 1.8581. All right, so we'll just leave that as exact value or its approximate value as well. All right, next part. Now looking at the median. So it does say percentiles and the median, and they're pretty much doing the same thing. And when I was looking over this before I started this video, I was like, I've kind of jumped around a little bit. So I apologize in advance, because what we have here is we're looking at, in this part, percentiles, but then the question below it refers to just the median. All right, and then we have to find the median. And then I talk about the median. So I'm going to jump around with the theory first, and then we'll do those questions. And maybe I'll also show you that example before I do the questions. All right, so what it means by percentile is basically if we wanted to know, and as it says in this question, if we were marking a test and we wanted to know the the percentile, the 75th percentile, which you can see here, 75%. So what value did 75% of students get below? And you might also, if you've got extremely younger brothers and sisters who may be babies, and you remember when they were born, they often talk about their height, their weight, and even their head circumference in percentiles. So my son was a huge baby. He's also now a huge 13-year-old and had a huge head. So he was always in like the 95th percentile. So he was always one of the big babies. Maybe you even know what you were. So my niece, she was born at 24 weeks. So she was extremely premature and she weighed 500 grams. So she was down the other end. She's now 12 and is like every other 12-year-old girl. So completely fine. But yeah, born at 500 grams, so a tub of butter, which is just amazing. And my son was, in comparison, 4.5 kilos, so 9 times as heavy as her. Anyway, that's a little bit of information of how we would use percentiles in the real world. So you can just convert a percentage into a decimal. So you can see the 75%, we just let it equal 0.75. And we're basically saying, well, what is that upper limit? So we want to know how many students got, you probably do from 0, not negative infinity, if you're looking at marks on a test. So 0 to what value did 75% of students get? Okay, we call that the 75th percentile. Or if you wanted to do the 25th percentile, the 90th percentile, you just convert it, or the value Q here is representing the percentile. So you just convert it into a decimal, your percentage into a decimal or your percentile into a decimal. All right, so exactly the same thing. We're just finding the upper limit, okay, or maybe the lower limit, and Q is our percentile, which we need to put as a decimal. Now, the reason why we're talking about the median, and hopefully you know a bit about the median, I'm teaching it at the moment to my year 8s and my year 9. So I know that you've seen the median before. It is the middle value. So if you're looking at the middle value, it's halfway. So our percentile, instead of being 0.75, which is 3/4 of the way, what do you think halfway is? 0.5. So let's jump. Okay, let's talk about the median. So you can see here, they've let Q equal 0.5, okay, because your median is directly in the middle. And they've used M just to represent that upper limit, but you can use P. It doesn't really matter what letter you use as long as you answer the question correctly. So that basically means either side of M, you have 50% of values. So your area on both sides would be the same. So this curve, even though it's skewed, so it's not symmetrical, it's skewed. And if you're thinking about, well, is it positively skewed or negatively skewed? Remember, we're the little girl at the top of the hill and we're sliding down. Oh gosh, why am I doing that? Didn't think it was going to be that big. Big arrow. All right, let's do that again. All right, so here you are on top of the slide and you're sliding down in the positive direction. So we call that positively skewed, but that's not really a huge part of this course. But if you're doing further maths, you should know that already. So that means the area is the same on both sides. Okay, getting carried away. It's been 20 minutes. Okay, so example 8 actually shows you a question with the median. So I'll get my highlighter out. So what are we doing? Suppose the probability density function of weekly sales of topsoil in tons is given by the rule. Okay, so we've got a function here from 0 to 1. And we have to find the median. So our lower limit is 0, so you can see 0 has been put there. And we want to find the median, so we can use M. If you want to use P, that's fine. You can use any letter, as long as you write the answer. And we're letting it equal 0.5 because remember the median has to be halfway. So then we're just solving for M, and that one there is not too difficult, okay? But because it does end up becoming a quadratic, and that one there you would have to probably use a quadratic formula to solve if you were doing it by hand, otherwise easily done on your calculator. We've got two solutions, all right? M equals 0.293 or M equals 1.70. Usually if you're given multiple solutions, you always check your domain. Okay, so X has to be between 0 and 1. So we're going to only accept M is equal to 0.293. Okay, so always when you've got your answer, especially if you're working with a quadratic or cubic or whatever, and you've got multiple answers, always go back and say, okay, which one do they all work or just one or two of them? All right, so you need to always think of your domain. All right, easy to do on the calculator as well. Okay, so we're just doing solve this time. So we're solving for M. Okay, now we're going to go back up to these questions. Because you would probably be fine doing these questions on your own. So this video has been going for 23 minutes. I would strongly encourage you to have a go at doing them on your own. Because with question 7, part A and B, that relates to stuff that we did in 15A, and question C relates to what we're doing now. Question 9, we're just finding the median. All right, and then if we scroll along, just because I like, and there's a little summary for you. Question 11 might be a little bit harder because we've got going to be working with two functions. So I might show you, if you want to fast forward to question 11, please do. And then I put in question 13 because we got a trig function there. So question 11 and 13, oh gosh, keeps going. The methods notes that keep on giving. All right, and I think 14 is the last one. So I would strongly encourage you to have a go at doing them on your own. I'll keep talking you through it, but as entertaining as I like to think I am, I also understand that, you know, sometimes it can be a bit much listening to a video for so long. All right, so I'll leave it to you. I'm going to keep talking. If you want to pause and have a go on your own, please do. All right, so question 7, the time x seconds between arrivals of particles at a radiation counter has been found to have a probability density function f with the rule. Okay, so we've got f of x equals e to the negative x when x is greater than or equal to 0. Don't worry about the 0 part unless you've got a graph, so make sure you always consider that when you're graphing. All right, so for question A, we're finding the probability that x is less than 1. Now these I'm going to do on the calculator just to keep the video shorter, but if you want to check your working, just do it on through your textbook. Okay, so x has to be less than or equal to 1. So we want to go from 0 to 1. And we're doing e negative x dx. All right, let's just, that's not a hard one to do by hand, but let's just do it on the calculator. Oh, I feel so bad doing it on the calculator. That's not even the calculator. All right, it's probably good to have a bit of practice on the calculator anyway. All right, we're going from 0 to 1. I'm just giggling because I feel like it's such an easy question to do by hand. All right, so there's your exact value. So negative e to the power of negative 1 plus 1. And if we were going to write that without the negative power, and usually we write 1 first, so I would probably write that as 1 minus 1 over e. Now remember, you do need to be able to transpose. So even if you could do this on your calculator, remember your exam might ask you to put it in a specific format. So just be aware of that. Let's put it in decimals. So 6321. All right, moving on to question B. Also not hard to do by hand, but we'll do it on the calculator. I might just do it over here so we can leave the bottom for question C. There we go. All right, so this time we're going from 1 to 2. Now remember, with continuous random variables, it doesn't matter. So the important word here is continuous. So it doesn't matter what sort of inequality sign you're using. Okay. All right, let's get back up my pen. Okay, so we've got e to the negative x dx. All right, we'll just do that on the calculator. Again, easy to do without the calculator. But I'm just going to copy. So we're going from 1 to 2 now. So it's going to give me the exact value first. All right, so you can write that as 1 over e minus 1 over e squared. Or if we were doing decimals, 0.2325. All right, let's do question C. All right, so this is the new stuff. All right, so we're finding the median of x. So we're going from 0 to some value, which we're calling m. All right, our function is e to the negative x dx, and that is equal to 0.5. So remember, the median is halfway, so it's 0.5. So we only want to find half the area. All right, and then maybe I'll do this one by hand because I haven't done one yet, even though there was an example there. All right, the antiderivative of e to the negative x is negative e to the negative x. 0m equals 0.5. All right, so let's just substitute in m and 0. So negative e to negative m. And then we've got to put in the 0, so we've got negative. Now, don't go thinking every time you substitute in 0, it's going to be 0. For this one here, because x is in your power is 0, and anything to the power of 0 is 1. So effectively, this is going to become 1, but I'm just going to do the substitution first. So minus negative e, we don't write negative 0, so I'll just write 0. All right, and that's equal to 0.5. Now, what I hate seeing, and I don't think too many of you do it, don't keep writing linearly. Okay, go down like I do. Not because it's what I want, but it's because if you're, sometimes it's not equal. So let's say you then said, okay, well, now I have to square that and add 2. They're not equal, okay? Not that you would do that, but, you know, you do see it pop up every now and again. So always, when you're doing it, start the next line. So I need to go up here. All right, so we're going to have e to the negative m. So negative, oh, let's just leave it as negative. All right, and then minus negative e is going to be plus, sorry, e to the power of 0 is 1. 1 minus negative 1 is plus 1, 0.5. All right, now I was going to do some fancy stuff there, but I won't. All right, so we've got negative and a negative, so I'm going to turn them both into a positive. So you know what I'm going to do. I'm not a fan of decimals, so I'm going to rewrite that as a fraction. Actually, I'm going to write this as a positive power 2. All right, so e to the negative m is just 1 over e to the power of m, and then 0.5 is just a half. Remember, they become both positive now because they were both negative before. All right, so that means e to the power of m is equal to 2. And to get m on its own, we just take the natural log of both sides. All right, so that leaves us with m equals natural log 2. All right, so did get the right answer, which is always good. All right, so let's do on the calculator solve. What are we doing? Okay, definite integral. It's a lot of working there by hand, but you do need to know how to do this by hand. Don't think you can do everything on your calculator, because in exam 1, no calculator, guys. All right, which hopefully you know. Negative x dx. Now, in one of my classes, we were having problems when we were solving with a definite integral. And lovely Holly realised, sorry Holly to point you out, that, see the cursor, how it's a little cursor? So that's still with the x. So you actually have to make it a big cursor before you do equals. Otherwise, you might get an error message. So I remember a few people in one class were getting that, and maybe in the other class you were getting it too. But Holly realised right at the end of the lesson, and I didn't have time to share it with everyone. So if you get an error message, just make sure that your cursor, after writing the x, becomes a big cursor. So equals, because you'd hate to do that on an exam. You're like, why do I keep getting this error message? Okay, and that's why. All right, sorry. Just went off on a tangent. What's that? 0.5, comma m. Oh gosh, what did I do? All right, all this talking, and hopefully you picked it up, because I was looking at this definite integral up the top. That's what I did wrong. Going to m, silly me. I was looking at question A, and this was hiding the right definite integral. So you can see at C, that's what I had to put into the calculator. That's why I got no solution. After telling you all about, yeah, the right thing to do to write it, and then I don't even get the answer. Okay, so you could see they gave us the exact answer, but let's now put in the decimal. So 0.6931. All right, on your exam and also on your SAC, well, hopefully I remember every question on your SAC to tell you how many decimal places to put your answer to. So most of the time it's in exact form, but decimal values, it should tell you on the exam. Okay, question 9. A continuous random variable x has a probability density function given by blah, blah, blah. Find the median. And now it says 4 decimal places. Okay, so we're going from 0 to m. You could also go from m to 1. We should get the same answer. All right, 1 minus x to the power of 4 dx, and that is equal to 0.5. Okay, so you could do this, find the antiderivative of this. We've done that before. I'm not going to spend time doing it because it's already, that's not what I want. Already 35 minutes into this video. So if you want to do that by hand, and I strongly encourage you to do so, take the 5 out and then just deal with that antiderivative. So you're looking for, you're not using the chain rule, but you do need to have a look at the rule for that. All right, so again, solve. Definite integral. Don't forget, we're going from 0 to m. Hopefully you saw me do that last time. You're like, what is she doing? Sorry, my son's coming upstairs. This will be fun. Mom. All right, so let's finish. Sorry, I had to pause the video. Let's just get the calculator back. dx, remember your cursor. Actually, I might show you what will happen if we don't do that. Equals 0.5. Oh, now my son's getting food. Okay. And we get invalid syntax. And you're like, what have I done wrong? It looks perfect. And I'm just making sure it does. Oh, I did forget to put the comma in. Did a full stop anyway. Incorrect number of arguments. What have I done? Okay, so let's, small cursor. Oops, let's get rid of that. Small cursor needs to be big cursor. 0.5. Yeah, so if you want to know what my son came up for, he wanted money for Fortnite. I said no. All right, so there's your answer. It's given it to us in 4 decimal places. Oh, it's given it to us in decimal form. So let's just do it to 4 decimal places. So 1294. All right, and I think the textbook does do that, the working out for that by hand if you wanted to check how you're going. All right, so just jumping to question 11 now. So let me just get my pen. Oh, don't know why that happened. Try again. That's better. Okay, so let's read the question. So a continuous random variable x has a probability density function given by, so we've got x between 0 and 1 and 2 minus x when x is between 1 and 2. And then 0 elsewhere. So you could easily graph that. So x being two linear equations, so easy to graph, but just remember you've got to put the 0 elsewhere. And if you're also graphing it, just take into consideration your domains and have your circles correct as well. But I'm not going to do that because we're going to find the expected value. Okay, so the expected value, so we're just doing ex. Now we just do each function separately. So for the first one, we're going from 0 to 1. And it doesn't matter that we use 1 here. We're going to use 1 on the next definite integral as well. All right, so e of x is x times f of x. So f of x is also x dx plus, and now we're going from 1 to 2. And we've got x times that function, 2 minus x dx. So let's just tidy it up a little bit. I feel like I haven't left enough space again. Don't forget your dx's. Remember dx's on the end of your all definite integrals. So 2x minus x squared. 2x minus x squared dx. Now you can't take 2 out because the 2 only applies to one term, not both of them. And you can never take out a variable. Okay, so we're just going to leave it like that. All right, so we're going to set up, let's just solve this. So the first one, x squared, the antiderivative is x cubed on 3. I'm going from 0 to 1 plus 2x becomes just x squared. And then x squared becomes x cubed on 3. And we're going from 1 to 2. All right, so let's just do our substitution. So I'm going to substitute in 1. 1 cubed is 1. Then we've got minus 0, so that's all good. plus, and then we'll do the second brackets. So substituting in 2, we've got 4 minus 2 cubed is 8 on 3. Now I'm going to put brackets in. If that was a minus, it would confuse things. So I'm just going to put a square bracket there. And then a bracket around that, and minus, and then a bracket. So substituting in the 1 squared is 1 minus 1 cubed. All right, tidy it up. 4 minus 8 on 3. Now I'm just going to rewrite the fraction. Sorry, 4 as a fraction, so that's 12 on 3. Just makes it a little bit easier. Don't have to rewrite it all. 12 on 3 minus 8 on 3 is 4 on 3. And then we've got 3 on 3 minus 1 on 3 is 2 on 3, so minus 2 on 3. So and I know I said before don't go crossways, but I am here because I'm poor with space, but it's all equal. Everything that's in between the equal sign is equal. Okay, it's when you start introducing and saying, oh, I need to multiply this by 2 and that's when it doesn't become equal. All right, so we've got 5 minus 2, so, oh, is that just 1? 5, there you go. All right, so good. I like doing these questions, even though I think I said before I do them on the calculator, but it's good practice of your fraction skills. So you would hate to know the hard maths and get questions wrong because you've forgotten how to do fractions. All right, so if you feel like you need more practice with fractions, do these questions by hand. All right, part B, we've got to find the median. Now, we've got 2 functions, all right? So we've got to say, well, where would our median be? All right, so for the median, sorry, I just had to have a big pause. So I was just thinking about this question. All right, so when you're doing your median, and it doesn't really matter if you know what the graph looks like, but I can see we've got 2 linear equations. Basically, if we were looking at the first function of just x, dx, and because it's the median, we know it has to equal 0.5. Our lower limit is 0, so we're going to some value, which is the median, which we can call m. So you can solve for m that way, or if you wanted to do it the other way, we can go from m, so using the second function to m. So this, let me use my highlighter, it might be a bit easier. All right, so this second function is this one here. Or you could use the first one. So it doesn't matter. We can use both to find, or either one to find m. All right, let me just finish writing it down. So 2 minus x dx equals 0.5. Just make sure your lower bound and your upper bound are correct. Okay, so don't have the m in the wrong spot. Okay, so the first one is easier. So just doing x. So let's go ahead and do that by hand. Just because it's good practice. X becomes x squared on 2. And we're going from 0 to m. And it's going to be easy because we're at 0. And I love fractions, going to use fractions. Just try not to get mixed up with that. So we're going to have m squared over 2 equals a half. Multiply both sides by 2. Gives us m squared equals 1. So m equals plus or minus the square root of 1. Okay, so there's our solutions. Okay, so we do have 2 solutions, but we've only got one plausible solution, which is m equals 1, because using our domains, we've got to go from 0 to 1. So your median is 1 for that one there. All right, I'm going to skip question 13 for now because question 14 is quite similar. So let's do that and then we'll come back to 13. All right, so question 14, very similar. So if you want to press pause and do it on your own, please do. Okay, so we're finding mu. All right, expected value of x, the mean. Remember those words are interchangeable. So we're finding ex, which is mu. All right, and don't know why I didn't use my colors. Okay, so our first function, we're going from -1 to 0. And we're finding the expected value, so it's going to be x times 0.2 dx. You can put that 0.2 out the front if you want, but we're going to just do it all on the calculator anyway. All right, and then for the next one, we're going from 0 to 1. Remember, they're continuous random variables, so unless you're graphing them, the inequality signs don't make any difference with your definite integrals. Okay, x times 0.2 plus 1.2x. What's my problem there? I forgot to hug. So remember your bracket. So it's x times f of x. Don't forget your dx. All right, so let's just plug this into the calculator. All right. Okie dokie dokie. So negative, no. Sometimes I feel I get to a point where my computer doesn't like functioning. X times 0.2 dx plus definite integral from 0 to 1. It's at 0.2. You could probably do this one quite easily by hand, to be honest. Dx, and then 7/10. Lovely. And I already know where that's going to be, 0.7. Okay, so funny how smug I get, and then the answer's wrong. Did you notice what I did incorrectly on the calculator? Okay, I feel like Dora the Explorer. Swiper, no swiping. Okay, I forgot the x. X times. So I wrote it down. There we go. 2/5, and I think that's the answer. I can also do that without a calculator, so 0.4. And it's good because that's the answer. All right. Part B, finding the median this time. So remember, similar to before, let's just use the first one because actually I like, well, 0.2 is probably easy to work with. What are we doing? The median. So we're going from -1 to m, 0.2 dx equals 0.5. Shall we do this one by hand? Not that I can really hear you answer. So 0.2, if we were doing 0.2 as a fraction, it's 1/5. So that becomes 0.2 times x. So any constant, you just then multiply it by x. So this is going to become x on 5. So either 0.2x or 1/5 times x, which is the same as x on 5. -1 m equals 0.5. Okay, so then we've got m over 5 minus -1 over 5 equals 0. Whoa, let's put that as a half. And let's just change that half. I could write 2.5 over. I'm just going to, not nice maths, but I'm just going to write it there. So then we can get rid of all the denominators. So we're left with m plus 1 equals 2.5. So m equals 2.5 minus 1, which is 1.5. So your median equals 1.5. All right, so this is where it would have been good to also check the answers, and a good lesson. All right, the median is not 1.5 because what did I say in the previous question? Always check whether it fits into the domain. Does 1.5 fit in that domain? No, it doesn't. So then I have to go on and do the next one, which is quite annoying. All right, so let's just write that down for the people who don't listen to the videos. M cannot equal 1.5 because x is between -1 and 0. So, running out of room. Okay, so let's do now from m to 1. Okay, so 0.2 plus 1.2x now equals 0.5. Let's just do that on the calculator. All right, so solve. We had our practice with fractions. Okay, so m to 1, and we've got 0.2 plus 1.2x dx. Get your big cursor, equals 0.5, comma, solving for m. Okay, so we've got, now this would be good to do by hand, and the textbook actually does it by hand. We've got 2 solutions. All right, so we've got m equals this and m equals that. If we're doing this on the, by hand, we know the solution has to be between 0 and 1. So our first solution, where we've got negative root 19 over 6 minus 1 on 6, clearly that's going to be negative. So it's got to be the second solution. So square root of 19 on 6 minus 1 on 6. And if we wanted to do that in decimals, five, 598. All right, so that was a good question to do, especially for that part B, because it goes to show that it's not always, sorry, I think I said for question 11, you can do it both ways, but that question, it did work because 1 was actually a part of both functions. But this one here, we got m is 1.5, so we couldn't use that value because it was outside our domain for that first function. So then we had to use the second function. All right, and then for the second function, if you did that, as you could see on the calculator, or if you did it by hand, we do get 2 values for m. So we've got to consider the domain. It has to be between 0 and 1. So we take that value there. All right. Question 13. All right, so hopefully this one won't take long. All right, a probability model for the mass of a 2-year-old child is given by, find the median value m of x. Okay, so let me just get my highlighter because I want to highlight some important parts. Here's our domain, and we want to find the median. Okay, and we've got our function. All right, so we're going from 7 to m. Then our function is pi on 20 sine pi x minus 7 on 10 dx equals 0.5. Now you could go ahead and do this by hand. So I'm going to do it by hand just because I like a challenge, and why not make a few more mistakes tonight? So 7 to m. All right, this is where I'm going to get stuck. The antiderivative, I always get which one's negative and which one's positive. So I'm just, actually we're not, sorry, not doing that just yet. Pi x minus 7, not finding the antiderivative yet. I was just taking that pi on 20 out, which I probably should have done in the previous question. All right, so your antiderivative, so the pi on 20 can stay out the front. You could take it to the right-hand side if you like. It doesn't really. So the antiderivative of this, I'm going to cheat and do it on the calculator, but you should be able to do it by hand just because I would need to scroll through the notes just to check. All right, so we've got sine pi x minus 7 on 10 dx, and remember, what did I do wrong? I think I forgot bracket. Oh, not there. Hopefully that's all that's wrong. Okay, so there is our, it's negative. Okay, so there's our antiderivative, which you should be able to do by hand. All right, without your calculator, but I'm just going to be sneaky. So we've got negative 10 on pi. So I'm just going to take that out the front as because it looks a little bit complicated when we don't. So I've just taken the negative 10 pi on pi out the front of cos instead of just writing it as a fraction. Then we've got pi 10. I'm going to write it exactly how it had it in the question. So pi x minus 7 on 10. So I knew what this coefficient of cos should be, but I couldn't remember whether it was negative or positive. All right, so we're going from 7 to m equals, let's put it in as a fraction. Okay, so let's substitute in m first. So we've got negative 10 on pi cos. Now I'm going to skip I have to put m in anyway. Pi. Maybe I can't do this by hand. On 10, because we've got that m. We'll see. Minus 10 on pi cos. Let's go as far as we can by hand. 0 minus 7 on 10. Nope, not 0 minus 7. I knew we should have had a 0 there. Okay, 7 minus 7, because x is 7, so 0. 0, that's a pi. Okay, just make sure I've got everything in there correctly. Equals, let me just, I don't think I can move, can I move you over? Okay, so we've got a half times 20 on pi, so it's going to be, so I'm bringing that pi on 20 by multiplying it by its reciprocal, which is 20 on pi. So 1 times 20 on pi is, so 1 half times 20 on pi is 10 on pi. Okay. Oh, I can see something nice is happening here. All right. Pi m minus 7. All right, so now we've got two negatives, so we've got plus. Tell me this is probably going to, so cos of 0 is 1. So then we've just got plus 10 pi. Cool, that's good. Equals 10 pi. All right, so, that's going to get rid of that, isn't it? So that's going to be 0. And that's going to make that 10. Okay, let's keep going. So cos pi m minus 7. All right, so this 10 over pi and this 10 over pi do cancel each other out, and then that disappears. So it's just going to be 0. All right, so all right, so inverse cos of 0 is 1. Didn't say that too carefully. Oh. Okay, not 1, pi on 2. I got a picture of the unit circle. I don't know why I said 1. All right, let's just tidy it up a little bit. Okay, so those pi's do cancel each other out. So we're left with m, that should be 1, minus 7 equals 10 on 2, which is 5. So m equals 7 plus 5 is 12. All right, and that's the answer. Woo! It's always exciting, especially when you do something that, I suppose, complicated by hand. Yeah, so it wasn't too hard, except, obviously I had to use a calculator for a few of the trig stuff. But yeah, hopefully you know the antiderivative, and also your exact values, which I had to check on my calculator. All right, so good question to do by hand. And we just hit the 1 hour mark. So girls, all the best. Bye.